In this chapter, we implemented the infrastructure layer of the clean architecture. We added Entity Framework Core, configured our domain entities to be mappable to the database. We added the SQL connection factory, which was required for Dapr, and we added support for optimistic concurrency and publishing domain events. In the next chapter, we are going to be implementing the presentation layer, and we are finally going to run our application. In this chapter, we are going to implement the presentation layer of the clean architecture. The presentation layer acts as the entry point into our system, and it's usually a RESTful API, a gRPC service, or even a single-page application. The main responsibility of the presentation layer is to take requests that are coming to our system, package them up into commands or queries, and send them using the mediator pattern to the application layer. In this chapter, I'm going to show you how to implement the presentation layer using a .NET 7 Web API. We're going to create controllers that are going to hold our endpoints. We're also going to add some middleware to solve a cross-cutting concern. The presentation layer acts as the composition root for our services, and this is where we are going to implement dependency injection for all of our layers. And lastly, I'm going to show you how to set up container orchestration with Docker Compose so that we can run our application together with the external services that we are going to need. So without further ado, let's dive into the code. Let's start by adding our Web API project to the source folder. So I'm going to add a new project, and I'm going to pick an ASP.NET Core Web API. Let's click Next. I'm going to give it a name of Bookify API. We're going to use .NET 7 as our framework. We're going to enable HTTPS and Docker support, and I'm going to pick Linux as the Docker operating system. I'm going to use controllers, and I'm going to also add Swagger. So with this setup in place, let's create our Bookify API project. Let's examine what we get in our API project out of the box. Here's the program file, which we are going to use to set up our dependency injection and our middleware. So I'm going to get rid of these comments. We are adding controllers into our services. This is adding Swagger support so that we can see our endpoints. Then this is adding the Swagger UI. And here we have some middleware. For the time being, I'm going to disable the authorization middleware because I want to be running my API without any authentication in place. Later in the course, I'm going to show you how to add authentication using the Keycloak identity provider. Let's take a look at what we have in the controllers folder. You'll see that we have some weather forecast controller, which is added by default. I'm going to delete it. And I'm also going to delete the weather forecast class, which was added to support the weather forecast controller. Inside of the app settings JSON file, we have our configuration for the application, and we're going to be using this to set up our connection strings and any other configuration that we might need. And lastly, let's examine the Docker file that was generated for us by default. You don't need to know everything about Docker to figure out what's going on or to be able to run this successfully. You just need to have Docker installed on your system and Docker Desktop running. Here's a short overview of what we have in this Docker file. First, we are setting up the ASP.NET 7 image as our base image to build the Docker container. Then we are exposing the ports for our API. Then we are copying the project files into the container itself, running .NET Restore. Then we are building our project. And lastly, we are publishing the project so that we can finally run it using .NET Run and specifying the DLL for our API. This is what we get in our Web API project out of the box, and now let's go and configure our services. I'm going to add project references to the application and infrastructure projects so that I can add the corresponding dependency injection calls and configure the services that are defined in these projects. Let's start by calling builder services add application. This is going to add the using statement for the Bookify application namespace, which is where we define the add application method. Let's also bring in the services from our infrastructure layer. This method expects an iConfiguration instance, which we can pass from builder configuration, This is all that we need to wire up dependency injection because we already added the respective service registrations in the application and infrastructure projects. Now it's time to add some controllers. I'm going to create a new folder inside of the controllers folder, and I'm going to call it apartments. Let's add our first controller inside of this folder, and I'm going to pick an empty API controller. Let's click add, and we're going to give it a name of apartments controller. This is what Visual Studio is going to scaffold for us, and we can start working from here. The API controller attribute is there to tell the .NET runtime that this is supposed to be an API controller. It's more lightweight and requires less services, and it's a little bit more performant than an MVC style controller. Let's update the route. Instead of the controller template, I'm going to hard code my route to apartments just to make things explicit. And you'll notice that this controller is inheriting from controller base. This is also what an API controller should do because you don't need everything that's exposed by a base controller. Let's go ahead and define our first endpoint. It's going to be a get endpoint, and it's going to return a task of iAction result. I'm going to call it search apartments, and it's going to have two arguments. One is going to be the start date for our search, and the second is going to be the end date for our search. I'm also going to include a cancellation token to the list of arguments so that we can pass it to Mediator when we send our query. What are we going to define in the body of our endpoint? First, let's create our query because this is a get endpoint, and get endpoints are used for querying data. Let's create a new instance of the search apartments query, and we're going to pass it the start and end date values that we get from our endpoint. Then we need a way to send this query using Mediator, and for that we're going to inject a service into our controller which is called iSender, and it's available in the Mediator namespace. Let's inject it from the constructor, and now inside of our endpoint we can say result is equal to sender, and we're going to send our query and also pass in the cancellation token. The result object that we get back is a result containing a read-only list of apartment responses. Because this query can never fail, I'm just going to say return OK, and I'm going to return the list of apartment responses that is returned by our query. Let's create another feature folder inside of the controllers folder, which I will call bookings, and we're going to add another API controller inside, and I'm going to call it bookings controller. I'm going to place the API controller attribute on top, and I'm also going to hard code the route to API/bookings. I'm going to inject the iSender from Mediator because I'm going to be using it to send my queries and my commands. Let's add our first get endpoint. This is going to be the get booking endpoint, which is going to accept an ID of our booking from the route, create a new get booking query instance, and send it using Mediator. Then if the result is successful, it means that we found our booking, and we're going to return a 200 OK result containing the booking response. Otherwise, we're going to return 404 not found. Let me add one more endpoint. This is going to be a post endpoint to reserve a booking. It's going to accept a reserve booking request, which is our request object containing the data that is required to reserve a booking. I'm going to add this request object inside of the bookings folder, and here is what the reserve booking request looks like. It accepts an apartment ID, a user ID, and the start and end date for the booking. Then inside of our bookings controller, we are mapping our reserve booking request to the reserve booking command. We are sending this command using Mediator, which is going to trigger our command handler. If this is a failure result, we are going to return a bad request response containing the result error. Otherwise, if the result is successful, it means that we were able to reserve the booking, and we're going to return a 201 created response. This is a RESTful API convention, and the response is going to contain a location header with the route to the get booking endpoint and the ID of the newly created booking. I want to comment on why I am using a request object here instead of exposing my command directly. the reserve booking command is part of my internal API, and it's only valid inside of the scope of my application. You don't want to expose this on your API endpoint because then you are coupling your endpoint and the definition of your command. This is leaking information about your internal API, which you never want to do. And secondly, it's preventing your command from evolving separately from your endpoint. You might want to introduce some additional information on the command, which you can populate inside of your API request, and you wouldn't necessarily want to expose all of these values as part of your API contract. Now that we have a few endpoints in our API, let's see how to set up container orchestration with Docker Compose and run our project together with a database. I'm going to scaffold the Docker Compose project by adding container orchestrator support. I'm going to choose Docker Compose as my container orchestrator, and I'm going to click OK. For the target operating system, I'm going to use Linux because this is what I'm using in my setup. If you are using Windows containers, then you would pick this option. So I'm going to go ahead with Linux and click OK. This is going to add the Docker Compose project to my solution, and we are interested in the Docker Compose YAML file. Right now, we have only one service configured, which is our Bookify API. This is the image that it's using, which is built from the Docker file that we have in the Bookify API project, and this is the route to the Docker file in our file system. Let's open up the Docker Compose override file, and I'm going to override the HTTPS port, which is 443, and I'm going to expose it on my local port of 5001. Now I'll be able to access my API on this port when I'm calling the endpoints. Let's go back to our Docker Compose YAML file and add a few more things. I'm going to give our API container a more user-friendly name, and I'm going to add the configuration for our database. This is the service name that I'm giving it, which is BookifyDB. I'm using Postgres as my database, so this is what I'm specifying as the image that I want to use for this container. I'm giving the container a friendly name of BookifyDB, and I'm setting up some environment variables. I'm saying that the Postgres database should be called Bookify, and I'm defining a default user with the username and password of Postgres. This part is really important, which is setting up our volumes. I'm mapping the internal folder in the container which holds our database data to the .containers/database folder in our file system in the project. This is going to allow us to persist the database when we shut down the container, and the next time when we run it, it's going to use the existing database instance. And lastly, I'm exposing the Postgres default port, which is 5432. I'm also going to decorate our Bookify API service, and I'm going to say that it depends on the Bookify database to be able to run. Now let's go ahead and add the connection string to our Postgres database running inside a container. I'm going to add the connection string inside of the app settings development JSON file, and I'm going to add it inside of the connection strings section. The name of my connection string is going to be database because that's what I configured in the infrastructure project, and here's how you can connect to a Postgres instance running inside of a container. The host is going to match our service name in the Docker Compose YAML file. The port matches the one that we exposed on the container. This is the default database and the username and password which we configured in the environment variables. You should now be able to start your Docker Compose project, and if we navigate to Docker Desktop, you'll see that as our solution is building in the background, we're going to have our container images starting up. So here's our API container, and here's our database container. Also, since we enabled Swagger, if I open up my browser on the localhost 5001 port, we are able to access it on the localhost 5001 address and navigate to swagger/index.html. This is going to contain the API endpoints that we defined in our controllers. Here's the get endpoint that we defined for getting the apartment, and then the get booking by ID endpoint and the reserve booking post endpoint.